Welcome to the project demonstration of Arrhythmia detection, disease detection by using Raspberry Pi 02W we are using here. So we have interfaced the ECG sensor modules to the Raspberry Pi board by using Arduino UNO. So here we are using ADE8232 ECG module, so which will take the electrodes inputs from these three electrodes, and the data will be analyzed and will be converted into the analog data. So as we know that Raspberry Pi doesn't have the inbuilt A to D converter, so that's why we are going to use Arduino UNO to read this data and to convert that analog data to serial. So the serial data will be given to the serial pin of our Raspberry Pi 02W, and from there we are coded the Raspberry Pi in Python language, and that code was loaded into this 32 GB memory card. And the code steps consist of read the data from serial ports, and also here we have the steps like we can select the dataset mode or a real-time mode directly. So by switching this selection mode, like above is a dataset mode, below is a real-time mode. So coming to the real-time mode, so when we place that in real-time mode, the real-time data will be captured from the ECG sensor. So we should place these electrodes on our body. So consider like here we wrote that RL nothing but right leg side, and the next RA nothing but right arm, and next LA nothing but left arm. So we need to mount these so-called electrodes on your body, the respective location, and after that the Arduino UNO will capture the data. So there are the three pins are interfaced to the UNO board. So the two are the digital inputs. So those two pins are inform the UNO board about this proper connection of these three electrodes. And another is A0, that's the analog input. So from this AD8232 pin to the UNO board, and from there we are going to convert the analog data to the serial and input to our Raspberry Pi. So there we are going to calculate that, and also we are going to find the diseases. So the diseases here we are going to calculate that hyperkalemia disease, hypercalcemia, and high heart rate tachycardia, and high heart rate bradycardia. So here the total we are going to identify the 6 kind of diseases: heart rate related tachycardia and bradycardia, and the next hyperkalemia, and next hypocalcemia, and next hypokalemia, and next hypertrophy. So these are the 6 different diseases. So coming to the heart rate tachycardia, bradycardia, that will be directly identified by the heart rate related one. Remaining 4 are based on the PQRST signal interval duration and intervals limitation. Whenever the QT is below that, so then it's considered as a hyperkalemia disease. Like that we are going to identify that, and that will be displayed on this 16:2 LCD screen. So this is the in real time mode directly. And coming to the dataset mode, so there as we know that, so in order to find this diseases, we should place this to the deceased person only. So here we have coded this Raspberry Pi with datasets of predefinedly deceased dataset, which we have downloaded from the Cargill datasets. So there are remaining 4 datasets. We have loaded the 5 datasets in that. One is the normal datasets, normal heartbeats, normal ECG signals, and remaining 4 are the diseases are like hyperkalemia, hypocalcemia, hypokalemia, and hypertrophy. So these are the 4 datasets we have loaded along with normal datasets. So that will be entered from this 4x4 matrix keypad. So and also based on this abnormal disease detection, so Raspberry Pi will on the pacemaker. So the pacemaker is controlled by this 9 volts battery. So we need to connect the 9 volts battery to this one and properly to this. So whenever the Raspberry Pi booted successfully, then there will be a welcome message on the LCD screen. After that only we need to connect this battery to the defibrillator pacemaker. So here the pacemaker working principle is we are going to generate the signals based on the disease. That signal will be amplified by using this step up transformer. So from these 2 electrodes we are going to get the signals for the stimulation purpose, for the electrical signals which are sufficient to for the heartbeat and heart purpose. And the next let us see the demonstration, and before demonstration let me explain you the connections. So as we have explained, ECG connection to the UNO board at pin number 10, 11 and A0, and first pin is connected to the Raspberry Pi 02W at 15th pin, and LCD is connected at pin number 17, 22, 27, 9, 10, 11 pins, and Raspberry Pi is connected at 5, 6, 13, 19, 26, 21, 20 and 16. And next, the selection switch interface at the pin number 12, and also one more LED indication, just it will show the status of the Raspberry Pi booting successfully done, and which is interface at the 18th pin. And next, this pacemaker pin was MOSFET pacemaker driver board is connected to the pin number 2 of our Pi 02W. So let us see demonstration. So just on the kit and wait, the booting was successfully done. It will take 15 to 20 seconds maximum duration. Once the booting was successfully done, let us place this in dataset mode for the demonstration purpose. So once the booting was successfully done, yeah, right, we got the welcome message, and after that it will show it is in dataset mode. So let us enter the dataset is 1. Right. Dataset 1 is loading. So it will take around of 5 to 6 seconds based on the data set memory, and then after it will analyze that. Right. So means instead of providing the input from the ECG signal, we have provided the same signal data which we are going to provide from the Arduino UNO to the Raspberry Pi. So then we are going to provide the dataset mode. So let's consider 5th. It's normal. So if you place the hand, place this electrodes to your hand, then whenever the disease was detects, then automatically, so we'll get the stimulations from these 2 electrodes. Right. Okay. And let us go with the real time mode. So in that, just you can change into the R mode. So let us, so heart rate is 0. After mounting these electrodes, so mount the electrodes properly into your hand, then only you can change the mode. Otherwise it will provide us the abnormal data, so wrong data, so that leads to the diseases also. Now in place into the real time mode. Right. So we have to mount that properly. So when showing 0, it's coming under the abnormal, that's why it's showing the disease over there. Right. So it's normal, as you can see that. So once it's matches to the skin resistance properly, and then it will show you the normal condition and along with diseases and heart rate. Thank you.